Hello everyone, welcome to today's complete beginner's guide to ArcGIS Desktop. Today we are going to talk more about ArcGIS Desktop and give a practical demonstration of using ArcGIS Desktop. So in this complete guide, we will cover ArcGIS Desktop and its product levels. This will help you to install the appropriate ArcGIS Desktop for your spatial analysis. After the product levels, we'll move to ArcGIS Desktop types or applications, and then we will move to introduction to ArcGIS user interface. As a beginner guide, we need to learn about the ArcGIS interface so that when we see it, we'll be able to familiarize ourselves with it. So I'll take you through a step-by-step demonstration of how to familiarize yourself with the ArcGIS interface. After familiarizing ourselves with the ArcGIS interface, we need to also find the various ways of loading data into the ArcGIS platform. There are several ways of loading data into ArcGIS Desktop. I'll practically demonstrate how to do that. And then after loading data, we have to view data, attribute data, how to edit in an attribute table or data, and so on. We also talk more about using the identifier tool to identify features on our ArcGIS interface. After viewing our data and those other aspects, we have to move to styling and labeling vector data. How to present or how to label and symbolizes vector data so that it will be appealing to someone, or it will make our data more meaningful. And then after styling our data, then we will perform a little bit of geoprocessing in our ArcGIS. So in performing geoprocessing, we need to make use of the click tool, intersect tool. You can also make use of the buffer tool, dissolve tool, and union tool. So this is what our video will cover. So let's go. First of all, as I indicated, we are going to talk about the ArcGIS desktops and its product levels. The first one is ArcReader. It's a basic data viewer for maps and GIS data, published in proprietary Esri format using ArcGIS Publisher. The software also provides some basic tools for map viewing, printing, and querying spatial data. ArcReader is included with any of the ArcGIS suites of products and is also available for free to download. That's the first product level of ArcGIS. Then we move to ArcGIS Desktop Basic, which is formerly known as ArcView, is the entry level of ArcGIS license. With ArcView, one is able to view and edit GIS data held in flat files, or view data stored in a relational database management system by accessing it through ArcState. One can also create layer maps and perform basic spatial analysis. The third product level is ArcGIS Desktop Standard, formerly known as ArcEditor. It's a mid-level software suite designed for advanced editing of spatial data in shapefiles and geodatabase. and it provides tools for the creation of map and spatial data used in GIS, including the ability of editing geodatabase files and data, multi-user geodatabase editing, versioning, raster data editing, and vectorization. ArcEditor is not intended for advanced spatial analysis. So the intent of it is not for what? Advanced spatial analysis. But you can use it to perform basic spatial analysis. And the final one is the ArcGIS Desktop Advanced, formerly known as ArcInfo. Allow users in the most flexibility and control all aspects of data building, modeling analysis, and map display. ArcView includes increased capability in the areas of spatial analysis, geoprocessing, data management, and others. So the ArcGIS Desktop Advanced can help you perform advanced spatial analysis. And if you want to perform advanced spatial analysis using ArcGIS Desktop, then you have to buy the ArcGIS Desktop Advanced license. For this, you have the flexibility and latitude to perform advanced spatial analysis. So now let's move to the ArcGIS Desktop itself. ArcGIS Desktop consists of several integrated applications, including ArcMap. ArcMap is the application used to view, edit, and query geospatial data and create maps. So, and that is the interface of the ArcMap. It is used to view. You can view your spatial data at this point. View. You can edit it. You can query and create maps. So let's move to the second aspect of ArcGIS Desktop, which is the ArcCatalog. ArcCatalog is a data management application used to browse datasets and files on one's computer, database, or other sources. So this is ArcCatalog. You can use it to load data into ArcGIS. You can use it to browse datasets and files on one's computer, database, or sources. And then, in addition to showing that data is available, ArcCatalog also creates users to preview the data on a map. ArcCatalog also provides the ability to view and manage metadata for spatial datasets. So these are the basic functions of ArcCatalog. 1. Manage metadata for spatial datasets. ArcCatalog also allows users to preview the data on a map. Allows you to preview data on a map. And that is the functions of the ArcCatalog. We also have ArcScene. ArcScene is an application that allows the user to view their GIS data in 3D and also available with a 3D analysis license. And that is the ArcScene, to view data in 3D dimension. And then we have the other one is the ArcGlobe. ArcGlobe is a 3D visualization application that allows you to view large amount of GIS data on a globe surface. So if you want to view large amount of data in a global surface, then you can use the ArcGlobe. And now there has also been an addition to these three ArcGIS Desktop applications. That is the ArcGIS Pro. The ArcGIS Pro application was added to ArcGIS Desktop in 2015 February. It had the combined capabilities of the other integrated application and was built as a fully 64-bit software application. So, and ArcGIS Pro is seen as a feature of the ArcGIS application. ArcGIS Pro is seen as a feature of the ArcGIS application, having more increasing functionalities and other to perform complex advanced geoprocessing and spatial analysis. So the Esri is gradually moving towards the ArcGIS Pro. So now let's move to our third part of this video. That's the introduction to ArcMap user interface. Introduction to ArcMap user interface. As I indicated, this is the ArcMap interface. This is it. When you open, this is how you see the interface of ArcMap. And then this, if you want to save your information, or you want to save your maps, you can just come here, save file, save as, and then you navigate to the place that you want to save it. Name, maybe map. So meaning that you save whatever things that you are working on. This, it has been saved. So that's how to save your map document. So with the save, when you say come to the file, if you want new worksheet, you can click on this, save as a copy, share, you can share your maps package, service. Here you can add data into your ArcGIS, and then here you can ArcGIS Online, sign into ArcGIS Online, page print setup, print preview, and then the rest. So here is view. If you want to view your data view, layout view. So if you want to compose your map, you use the layout view, and you can also access them below here, layout view, and then this is the data view. You work on the data view, and when you want to have a finished product, you go to what? The layout view. You can also bookmark things, insert. If you want to insert data frame, you can insert another data frame, and where, assuming that you are working on a project that have several layers, then you can add data frame through that, and you can remove it from here. Here, selection, this is for query. If you want to select certain properties within your data to conduct your analysis on, so you can use the selection method. So I'll load data into it, and we'll go by it and see how it works out. We have geoprocessing tools. This is the geoprocessing tool: buffer, clip, intersect, union, merge, dissolve. And as I said, we are going to perform some operation using this kind of tools. And then we have tools bar. If you want to access all the tools, if you have the advanced ArcGIS Desktop license, you can access almost complex tool for geoprocessing of your data. So you can use the you come to customize toolbars, and then you can select the particular, you can enable the particular tool that you want to use, and you can also access it by just right clicking an empty space here on the top. You can also have access to the toolbar. This is the window overview, magnifier, and so help. If you need more help from the ArcGIS Desktop, you can use help, and this help you can learn a lot of things. You can content whatever you want to learn, get started. What is ArcMap? You can learn a lot of things from here. A quick tour, ArcMap. You can basically use this ArcGIS help to learn essential things about the ArcGIS. You can do it, then you can close it, and then this is the table of contents. That's where you organize your layers. You see, when you click on it, it will appear. You can delete it, or you can take it out. Table of content, you can double click on it, it will appear. And this catalog, have you seen it? It's usually hiding on your right hand side. So when you click on it here, it will appear. You can take it out, and when you double click on it, it will appear. You can take it out from here, and then this is the search tool. If you want to find a particular tool, maybe you don't know that these tools have been categorized or grouped according to how they performed operations. So if you don't know where exactly the tool is located, you can use the search tool. You can just say maybe clip. You see clip coverage, clip analysis, clip data management. You click on it, the tool will come out. You put your data and you perform your clip operation. If you another tool like project. If your data is in different coordinate system and you want to project it to a different coordinate system, you can just use project. Click on a project. You see. So that is how to quickly find tools in ArcGIS Desktop. So if you know the name of the tool, just tap in here and the name will appear. You click search, it will appear. You click on it and you perform your operation. And this is also the Arc toolbox. As first I indicated, the tools have been categorized. So if your tool relates to 3D analysis can pick it from 3D analysis tools. When you click on the plus, you see then 3D features, CT engine, conversation, data management, data management, functional surface, raster interpolation, raster map, raster reclass, raster surface, triangulated surface, visibility. So things that relates to the 3D analysis, you can use 3D analysis tools. And then analysis tool here, you can have extract, overlay, proximity, statistics. That is the proximity, buffer analysis, and so on. Overlay, statistics, and extract. You can use this. And then we have conversion tools. If you want to convert data from one file format to another file format, you can use the conversion tools like Excel, from GPS, from KML, from PDF, from raster, from WFS, from JSON, metadata to card, to calendar, to coverage, to database, to geodatabase, to geopacket, to KML, to raster, to shapefile. KML data, if you want to view the data in Google Earth, you can convert it to KML so that you can view it. So that is the conversion tool that we talk about. We also have data interpretability tools, that's quick export, quick import. And then we have data management tools. Data management tool consists a lot of data tools that you can use to perform your operations, archiving, attachment, data. So if you want to have access to the particular tool, click on the plus tool. You have additional tools that you can use. Repair geometry, also add XY coordinates. So if you want to add XY coordinates to your points, you can use this tool to perform it. Generalization, geometric network graph, joins, and so projections and transformations. So first I type on project. So if you want project tool, you have to come to data management, you come to projections and transformations, and you then come to the project, which is similar, which is the same as what I type on the search button. So actually, if you know the name of the tool, you don't need to memorize where the tool is located. You can just type the name of the tool on the search tool, and then you can find the tool. But as you gradually work on the ArcGIS Desktop, you can familiarize yourself, or you'll be familiar with the places that these tools have been saved or stored. So we also have editing tools, erase point, extend line, flip, and so on. We have geocoding. If you want to geotag images to locations and so on, create address locator, rematch addresses, reverse geocode, standardize addresses, and so on. You can use geocoding tools. So ArcGIS Toolbox is a powerful toolbox that houses all processing tools and so on. We also have statistical analysis tools, which is here, interpolation, sampling network, simulation, utilities, and so on. So depending the tool that you want, you come here and find your tool that you want to project. So there are spatial analysis tool. If you want to work on spatial analysis, density, conditional extraction, generalization, groundwater, hydrology, interpolation, local, map algebra, math, multivariant, neighborhood, overlay, raster creation, reclass. All those operations can be performed by using spatial analysis tools. So that is it. Tracing analysis. So that is it. So basically, that is ArcGIS Desktop interface. How to familiarize yourself with ArcGIS interface. So now we familiarize ourselves with the ArcGIS interface. But let me add additional things to talk about. Here have the zoom in. Zoom in, you can use it to zoom in data. So a zoom in, this is our, let me bring my zoom in, this is our data. So we want to zoom in, so click on the plus, and then you do this. You see, you are zooming in. So if I want to zoom out, click on the mouse, you are zooming out. As simple as that. And then this hand, that's we call the pan the map by dragging. That is, pan the map by dragging. Click to re-center the map. Double click to re-center and zoom in. So when you click on this, you see, you can use it to move the feature around. That is the hand. And then we have full extent. If you want to zoom into full extent, you just click on it. you can also use here zoom to layer to zoom into the feature. And then we have fixed zoom in, and then fixed zoom in and fixed zoom out. You see, fixed zoom in, fixed zoom out, and then go back to previous extent. Assuming that you've made a mistake or something, or you want to go to the previous extent, you can just click on this, the arrow. If you want to go to forward, go to next extent. See, you can just use them. This one is a select features tool. If you want to select a particular feature, you can use this. You see, I've selected this, and then you can meaning this has been selected. So if you open the attribute table, it means that one selection out of 34. That is it. So if you want to do a selection, that's another one method of doing selection. You can also do selection using the attribute table. You can just select it from the attribute table, and it has been selected. It has been selected. And you can clear selection from here. So you select this and clear selection using this. You can select elements, and then this is the identifier tool. Identifier tool is used to identify features. So if you want to find out details about a particular feature, you can use the identity tool. You see this it has given us details about where I click on. This GH rails, railroad, and then we have value. FID is 8, shape is a polyline, FID underscore rail underscore D, this code single, FID ISO Ghana, GHA, and so on. Country is Ghana. So the identifier gives you detailed information about a particular feature. So, and we also have this tool, measure tool. So if you want to know the length of a particular river, road, place, or any place, you can just use that. This tool. See. So here, land measurement segment is 14,350 meters. You just see. Can use it too. So that is it. Basically, measure tool is used to measure this features on your map. And we also have find tool here. Find tool. If you want to find a particular location, you can just type that particular place that you want, and you click find. And then we have find a route, go to XY. As usual, you know the latitude and longitude of a place you want to find it on the map. You can just enter here longitude, and then you type the latitude here, and you'll be able to find the center of the place. That is it. Basically, these are important tools that you need to know on the ArcGIS Desktop. So now we have to move to our next stage of our video, that is working with vector data. As I was doing the demonstration, I have loaded some data into ArcGIS. So, but I want to give more details about how to bring data into your ArcGIS Desktop. There are several ways of bringing data into ArcGIS Desktop. One way is through using what ArcCatalog, as I indicated in my earlier summation. I said that ArcCatalog can be used to load data into your ArcGIS Desktop. You can also use to view data on your ArcGIS Desktop. So with this, I'm going to, when you go to your first here, what you need to, you have to folder connection. You have to first of all connect your folder. So when you right click on folder connection, you connect to folder, you click on it, navigate to the particular folder that your data is in. So if my data is in this, click on this and click OK. So I have added a folder. So I have two folders on the ArcCatalog window, and my data is in this folder. So you just click on the plus part, and then you see how the data is arranged. So I want the data on rows. So open the plus, click and drag your GIS rows. Don't leave your mouse, then leave it like this. So this is one way of bringing data into ArcGIS Desktop. Another way of bringing data into ArcGIS Desktop is making use of this plus and add data. Add new data to the mass activate data frame. Click on it. Navigate to where you save your data. Navigate to where you save your data. So when you come to folder connection, double click on it. My data is on this backup. Then any data that you want, maybe water, shapefile, art. You see, I have also added water bodies through the add data button. So these are two prominent ways of bringing data into ArcGIS. And this is usually how to bring data into ArcGIS, but I've brought in vector data. Vector data consists of lines, polygons. Consists of lines, polygons, polylines, and so on. So we have the rivers, buildings, shapefiles of them are called vector data. So with this, let's open the attribute table of the water. You see the attribute table of water. You see their shape is their polyline, because they are usually straight lines, lines, not really straight. And then description and so num underscore this and so on. That's usually the attribute table of the roads. So with this attribute table, you can add fields, and then you can even calculate shapes and other aspect geometrical properties. But I will deal with this in my next video. So you can select any of this by clicking on it, and it will be highlighted, so if you maybe want to select many of them, you can click on shift and then you click on the items. You see all these have been highlighted, and with this you can even export only these. Go to data, then export. You can name it if you want. You can also advise you to name it. If you want to, you can leave it like that. So meaning I have, you see, I have exported only the 5 rivers that I have selected. Zoom to the end. These are them. Have you seen? So that is how to view attribute table, select some features, and export those features from the rest of the features. You can also add data to your attribute table. Like you can add, not really data, you can add descriptions or other columns to your attribute table. So maybe if I want to add something, so you go to add field, you just name the maybe description, maybe it's number, short integer. Okay, so with this you can type in maybe the description of this road. So with this, to able to write or type in something on the description place, you need to activate your editor tool. So you can just, this is the editor, activate your editor. This is my editor. You can just come here, start edit feature, start editing. So with this you can add more information to your attribute table, maybe reverse tree, maybe the color or anything, maybe red, anything. Okay, sorry, I kept integer on the data type. If I kept text, you can write anything related to text, but this one is only numbers that can be written. 15, 17, 18. See, and after that you come save edits and then stop edit. So at any particular point, if you've added open attribute table, the description have been added. So that is how to open an attribute table, do selection, export certain selected features, and then add other additional fields into your attribute table. So that is it. So with this, we move to another stage, that is styling and labeling vector data. Styling and labeling vector data. That is if you want to give a good presentation of your data to be able to be understood very well, you need to perform styling on your data, or you do symbology, like you symbolize your data to make it easier to interpret. So with this, you can navigate your data, the data that you have, and then you load your data. So maybe let me load some data. Okay. Make a load some data. Maybe buildings. Let me remove the first this. So these are bar stops, and I want to symbolize these bar stops to make the data easier to understand. So you can just go to bar stops, right click, go to properties, you go to symbology, you can go to categories, name, let's see, that is it, how you symbolize your data. You can go to properties, can use difference, the quantities, you see, it gives you a range from 2492 to 405. This is the color of the that range, which is green, and then 5821, this is yellow. So when you see the various colors, it means that it corresponds to a range on your legend. Not on the legend, on the base, on the layers aspect. But when you are creating legend, all these will appear as part of the legend. So with this, you can easily understand your data than how it was. So basically, that is how to style your data. You can also even manually pick a symbol, and then you can change the colors to fit your own taste. to fit your own taste. You can also flip colors. So if the colors that you don't want, you want to flip them, you can use right click on this the symbol and then flip symbols. You can also ram colors and properties, flip symbols, and so on. You apply. So what about properties? Come to symbology. If you want graduated colors, you can do as well categories. Type. Then you can change the color. Let me use this color. And then add. So the type is only bar stops. Okay, but the names have different names of the bar stops. So if you want it to be bar stops, then it will be the same color. This is just a introduction to symbology. Introduction to symbology. But if you want more of this, will be in advanced tutorials. So that is it. So now that we are done with symbolizing our data, we want to see whether we can perform some kind of spatial geoprocessing analysis using the tools that I talk about. First of all, we are going to use the clip tool. The clip tool is an overlay function that casts out an input layer with the extent of defined feature boundary. The result of this tool is a new clip output layer. If you can picture a cookie cutter, it's like using the clip tool and carving out vectors and rasters is one of the most common operations in GIS. So one of the most common operations in GIS is carting vectors and raster data, because maybe our study area might be very large and we need a smaller area to be able to work with. So in that scenario, the clip tool is very useful. Or have a bigger features that overlap a smaller area, and we want to bring all the features within a particular confined area, then we can use the clip tool. So let me load the data into this. So assuming that we have our water. No, not this one. We have our water, and then I want to clip this to some place like a regional boundary of Ghana. So maybe let me open this. So it's a district. This is the particular district. So I want to find rivers within this district, Adansi North, in Ashanti region. So with this, I can just highlight the boundary or the district by selecting on the district. You can close it and right click on this and go to data export. You can save this. You can save this and say district boundary, district and the boundary. Don't give spaces. Here's shapefile. Then yes. So with this, you can even take this Ghana. This, you see, now we want to fan off rivers within this district. So we're going to clip all of them into this boundary. You can let me label it. Okay, it's just a Ghana. So with this, you can go to your geoprocessing tool, come to clip, input feature, you bring your rows or water, and the clip feature is the boundary. Bring it, and then okay. And wait for the operation to perform. Okay, it has been done. Have you seen? It has already clipped the rivers that are within this particular district. Click the rivers within this category, advancing up. It has clipped all the rivers within this boundary. So that's how useful the clip tool is. We are having a lot of water bodies. Have you seen them? A lot of water bodies. But I'm not interested in all those water bodies. I'm interested in water bodies within a dancing knot. And through the clip tool, I'm able to achieve my aim. And what is my aim? Having only rivers within a dancing. And that is it. Having rivers within a dancing. So that is basically how to use the clip tool. So now I will move to how to use the intersect tool. The intersect tool is very similar to the clip tool because the extents of the input features define the output. The only exception is that it preserves attributes from all the datasets that overlap each other in the output. The intersect tool performs a geometric overlap. All features that overlap with all layers will be part of the output feature class. Attributes preserved add multiple inputs. The tool assesses different data types, points, lines, polygons. So I'm just going to use the same data set that I used to demonstrate how to use the clip tool to also do the intersection. So for this is the clip. For the boundary, this is the boundary that I needed. I can even remove the output of the clip tool. Then I can also select the J water lines. So let's perform the intersection. Go to geoprocessing, go to intersect. So the input feature is our rivers. And then you can also add a boundary. Output features, you can select where you want to save your output. S1 tolerance is optional, you can leave it like that. You can leave it like that. Okay. Have you seen? That is the intersect tool. It has also performed certain the operation that it has performed is similar to the clay tool. So all rivers that intersect with the boundaries of the Adansi node are all within the Adansi boundary layer. So that is how the intersect tool is also carried out, how it is performed. And it is also very useful in GIS. Very useful in GIS. So now we want to carry out a dissolve. So assume that you have an area with adjoining boundaries and you want to collapse those boundaries, or you want to dissolve those boundaries to form a larger boundary. Then you can use the dissolve tool. The dissolve tool unifies boundaries based on common attribute values. In other words, dissolve merges neighboring boundaries if the neighbors have the same attributes. For example, if you want to remove the borders of the countries to form a continent, the dissolve tool is the tool to use. But you will need an attribute for each country and the continent it belongs to. So maybe I have this. Let me deselect this, leaving the admin. So you see, these are districts within the country Ghana. So if I want to dissolve all those districts to just form one boundary layer, then you can use the dissolve tool. Go to geoprocessing. You go to dissolve, bring this. So you can select the fields that you want to really dissolve. If you want all of them, it's okay. But if you want particular fields that you want to dissolve, so if I want to dissolve name and name 2 0, you see, Have you seen it? If you open the attribute table, you're able to dissolve name 0 and name 2, name 1. But if you want to even dissolve almost everything, you can also do that. Maybe if assuming that I want to dissolve everything, let's see how it will look like. Let's remove all the layers. Let's bring the rows shapefile. These are rows shapefiles. So our next tool that we will use is the buffer tool. Buffer tool, that buffers are proximity functions. When you use this geoprocessing tool, it creates a polygon at a set distance surrounding the features. For example, a buffer is a polygon or a collection of cells that are within a specified proximity of a set of features. So that is basically what a buffer tool is. So with the buffer tools, you can also use the geoprocessing, and then you come here, buffer. So we have different kind of buffers. We have just a single ring buffer and the multi ring buffers. So let's demonstrate how to perform a single ring buffer. So maybe our rows will be the input feature. The unit, maybe we want it to be in meters. And I will leave distance. So the distance, I want it to be 500 meters. I don't want to dissolve anything, it's optional. But if you want to dissolve certain fields, you can do that. Click OK. And wait for the buffer to be. So 500 meters range has been buffer has been performed along the road. So assuming that if you have a residential area and you have to leave a certain meters for maybe roads and so on, and people have encroached those lands, you can use the buffer analysis tool to find out which particular houses are within the certain distance, so that they can be demolished to pave way for the construction of such roads. So this is a single single buffering. So assuming that we want to perform several ring buffers within a particular road, then you can use the multi buffer. So with this, you can just type in multi buffers, multi ring buffer. You click on it, multiple ring buffer. So multi ring buffer, when you go to analysis tool, you can find this there, multi ring buffer. So you can analysis to come to proximity analysis buffer. We have multi ring buffer. You double click on it, you bring your input, which is the route in the distance. Maybe we want 200 meters, maybe 400, add maybe 600, add 800, and 1000. Okay, so these are so you can output features, you can put wherever you want to put it, save it wherever you want to save it, but this is just for demonstration. Doesn't matter where it goes. Can use them units, buffer units, meters, then click OK. It takes some time, so wait for the operation to be completed. Okay, the buffering has been done. So you see the colors. See 600, you see 800, you see 1000. So you can't label them so that you know, you see them very well. So that's basically how to carry out buffer analysis. You can also change the colors to the symbology aspect, unique values. So maybe distance, you can change the colors to whatever you want. That you see the colors has been changed. The colors has been changed. So that's basically how to carry out buffer analysis. So in summary, in this video, we talk about introduction to GIS, that is a complete beginner's guide to ArcGIS Desktop, where we talk about different product levels of ArcGIS desktops. We also talk about ArcGIS Desktops applications, that is the ArcMap, ArcLog, ArcView, that is ArcMap, ArcCatalog. We have the ArcScene, ArcGlobe, and ArcGIS Pro. We also demonstrated how to familiarize yourself with the ArcGIS interface, that's ArcMap interface. I also took you through how to work with vector data, and this we spoke about loading data into ArcMap using attribute table, using the identifier tool, and so on. I also touched a bit about styling in ArcGIS Desktop, how to carry out symbology in ArcGIS Desktop. And then we also talk a little bit about geoprocessing tools, where I practically demonstrate how to use the click tool, the intersect tool, the buffer analysis tool, where we performed multi-ring buffers and single ring buffers. Then we also use the dissolve tool. So thank you very much for watching this video. ArcGIS is a software. When you gradually practice it, you become perfect with it. So let me meet you in my next video. That will be a complete beginner's guide to ArcGIS Desktop part 2. Thank you very much and all the best. Bye bye.